Our solar system gets visitors. Most are familiar neighbors like asteroids and comets, locked in predictable orbits around our sun. But every so often, something new arrives, something from out there. In mid-2025, astronomers using the Atlas survey in Hawaii spotted a faint smudge of light moving in a way they'd never seen before. It wasn't bound to our sun, it was on a one-way trip, a cosmic tourist just passing through. They named it C2025F3, or Atlas. But the world would soon come to know it by its catchier nickname, 3 Atlas. This object was an interstellar interloper, a messenger from the vast dark expanse between the stars. The path it took told us everything we needed to know about its origins. It wasn't swinging around in a nice neat ellipse like our local comets. No, its trajectory was a hyperbola, a wide-open curve that meant it had enough speed to escape the sun's gravitational grip forever. It came from the direction of the constellation Aquila, the Eagle, but its true home was light years away, perhaps orbiting another star entirely. For a brief moment, its path intersected with ours, giving us an unprecedented opportunity to study a piece of another solar system up close. It was a race against time, as 3 Atlas was already on its way out, never to return. Astronomers across the globe scrambled to point their telescopes at this fleeting guest. From massive ground-based observatories in Chile and Hawaii to space telescopes like the James Webb Space Telescope, every available instrument was trained on the object. They tracked its speed, its brightness, and the subtle changes in its appearance as it journeyed away from us. We were like cosmic detectives, piecing together clues from photons of light that had traveled millions of kilometers to reach us. This wasn't just another rock, it was a pristine sample from a faraway place, carrying the chemical fingerprints of its birthplace. The universe, it seemed, had just sent us a postcard. Its journey was swift and its time in the spotlight was short. After making its closest approach to the sun, it slingshotted around our star and headed back out into the interstellar void. But its destination wasn't its starting point. Gravity had slightly altered its course, sending it towards a new, unknown patch of the Milky Way. We were just a brief stopover on an epic multi-million-year voyage. As it receded, growing fainter with each passing day, we were left with a mountain of data and a profound sense of wonder. What was this thing, and what secrets did it hold about the universe beyond our own cosmic backyard? The real show began as 3I Atlas ventured into the inner solar system. As it drew closer to the sun, the increasing heat started to work on its surface, causing it to brighten dramatically. This is typical behavior for a comet. Ice turns directly into gas, a process called sublimation, creating a glowing cloud called a coma and a tail that points away from the sun. By the time it made its closest approach to Earth in December 2025, it was just bright enough to be seen with a good pair of binoculars. A faint, fuzzy patch of light moving slowly against the backdrop of familiar constellations. For a few precious weeks, humanity could look up and see an object from another star system with their own eyes. This close pass was a golden opportunity for science. The Hubble and James Webb Space Telescopes captured stunningly detailed images, revealing features that were previously just blurry hints. Scientists use spectroscopy, a technique that breaks down light into its constituent colors, to analyze the gases boiling off its surface. This allowed them to create a chemical inventory of the object, like reading the ingredients list on a package from an alien supermarket. Every photon of light was a clue, telling a story about the object's composition and the environment where it formed, countless millennia ago and light years away. The public's imagination was completely captivated. This wasn't some abstract concept in an astronomy textbook. It was a real, tangible visitor from the stars. News outlets followed its journey daily, and amateur astronomers shared their own photos online, creating a global community of sky watchers all focused on this single, enigmatic point of light. It was a shared moment of cosmic connection, reminding us that our solar system is not an isolated island, but part of a much larger dynamic galactic ecosystem. We were witnessing a rare and beautiful event, a brief intersection of our world with the great unknown. As it began its long journey away from the sun, moving back into the cold, dark outer reaches of our system, the observations continued. Scientists watched as the activity on its surface slowly subsided, the coma shrank, and the tails faded. It was like watching a cosmic firework fizzle out, but the data it left behind was a treasure trove. The close approach had given us our best look yet at an interstellar object, providing clues that would challenge our understanding of what comets are, how they form, and the sheer variety of objects that wander the galaxy. The grand tour was over, but the scientific investigation was just beginning. When scientists got a good look at 3I Atlas, they knew it was special. It wasn't just another dirty snowball. One of its most bizarre features was its coma, the fuzzy atmosphere of gas and dust surrounding its nucleus. Instead of being roughly spherical, as is common with most comets, its coma was noticeably flattened, almost like a squashed ball. This suggested that the outgassing wasn't happening evenly across its surface. Something was restricting the flow of gas, channeling it in specific directions. It was the first big clue that 3 Atlas was playing by a different set of rules. Then there were the tails. Comets typically have two, a dust tail, which is broad and curved, and an ion tail, which is thin, blue, and points directly away from the sun. 3 Atlas had these, but it also had something else. A prominent anti-tail. This was a spike of dust that appeared to point towards the sun, seemingly defying physics. In reality, an anti-tail is an optical illusion caused by our viewing angle of larger dust particles left behind in the comet's orbit. But the one on 3 Atlas was exceptionally sharp and well-defined, indicating it was shedding unusually large, slow-moving dust grains. Perhaps the most puzzling features were the jets. As ice on a comet's surface turns to gas, it can erupt in powerful jets. On 3E Atlas, these jets weren't random. They burst forth in two distinct, narrow and almost perfectly symmetrical streams from opposite sides of the nucleus. It looked less like a natural, chaotic object and more like something engineered. These focused jets were what was causing the coma to flatten, and their incredible symmetry was something astronomers had never seen before on a comet, whether from our solar system or beyond. It was this strange, orderly behavior that really set the scientific community buzzing with questions. Putting it all together, the anatomy of 3I Atlas was unlike anything in our celestial catalogs. A flattened coma, a sharp anti-tail made of large dust particles, and two powerful, symmetrical jets. Each feature on its own might be considered an anomaly, but together they painted a picture of a truly unique object. It behaved like a comet, but a very, very strange one. These oddities were the puzzle pieces that scientists would need to assemble to understand the true nature of this interstellar traveler and the story it had to tell about its long journey through the cosmos. To understand just how strange 3I Atlas was, you have to compare it to the comets we know and love, our garden-variety comets. Most comets in our solar system, like Halley's Comet or Comet Hale-Bopp, originate from one of two places: the Kuiper Belt, a donut-shaped region beyond Neptune, or the Oort cloud, a vast spherical shell of icy bodies at the very edge of the solar system. These comets have been orbiting our sun for billions of years. Their surfaces have been processed by solar radiation, and their behavior, while sometimes unpredictable, generally follows a well-understood pattern of outgassing as they approach the sun. 3 Atlas broke the mold. Normal comets tend to have jets that are much more chaotic. They erupt from various active regions on the nucleus, shifting and changing as the comet rotates and different areas are exposed to sunlight. This results in a more uniform, spherical coma. The tightly focused, symmetrical jets of 3I Atlas were a complete departure from this norm. It suggested a fundamentally different surface structure or internal mechanism driving the outgassing. It wasn't the messy, unpredictable display we were used to. It was strangely orderly, almost controlled in its appearance, which was deeply perplexing for planetary scientists. Another key difference was the anti-tail. While anti-tails are not unheard of, they are typically faint and transient features. The one seen on 3 Atlas was bright, persistent, and composed of unusually large dust particles. This implied that the material being ejected from its surface was different from that of a typical comet. Normal comets shed a lot of fine dust, but 3 Atlas was throwing off larger, pebble-sized debris that lingered in its orbital path, creating that striking sunward spike. This pointed to a different composition and a different process for how that material was being lifted off the nucleus. Ultimately, the comparison highlighted that 3 Atlas was an entirely new class of object. It was a comet, yes, but it wasn't one of ours. It was forged in a different environment, around a different star, and had endured a long journey through the harsh radiation of interstellar space. These experiences had shaped it into something unique. It was like meeting someone from a completely different culture. They might look human, but their customs, language, and worldview are entirely their own. 3 Atlas was a cosmic reminder that our solar system's rules don't necessarily apply to the rest of the galaxy. Spectroscopy is a powerful tool. It's like a cosmic barcode scanner. By analyzing the light coming from 3 Atlas, scientists could determine exactly what it was made of. The initial readings were surprising. The gases boiling off its surface were extremely rich in carbon dioxide, or dry ice. While our own comets contain carbon dioxide, they are typically dominated by water ice. 3 Atlas seemed to have its priorities reversed. This high concentration of carbon dioxide suggested it might have formed in a much colder region of its home star system than where our own comets formed, a place where carbon dioxide could freeze out more readily than water. This discovery of abundant carbon dioxide also helped to explain some of its strange behavior. Carbon dioxide sublimates, turns from solid to gas at a much lower temperature than water. This means 3 Atlas began to show activity much farther out from the sun than a typical water ice comet would. It was already waking up while it was still deep in the cold outer reaches of our solar system. This early activity, driven by the vaporizing carbon dioxide, gave astronomers a longer baseline of observations and provided the first hints that its chemical makeup was unusual. The real bombshell came from analyzing the jets. While the initial coma was dominated by carbon dioxide, the powerful symmetrical jets themselves showed a different signature. Deep within the spray of these jets, the James Webb Space Telescope detected the unmistakable spectral fingerprint of water vapor. This was the smoking gun. It meant that underneath a surface layer rich in dry ice, there was a core of good old-fashioned water ice. The sun's energy was penetrating the outer crust, heating this buried water, and causing it to erupt in those 2 powerful, focused geysers. The comet had a layered structure like a cosmic onion. This layered composition was a critical piece of the puzzle. It explained why the outgassing was so strange. The carbon dioxide-rich surface created a general, weak coma far from the sun. But once the comet got close enough, the sun's energy punched through to the water ice below, which then exploded outwards through 2 weak points in the crust, creating the powerful, symmetrical jets. The object wasn't just a uniform block of ice and rock, it had a complex internal geology. Discovering this hidden water was a major breakthrough, connecting this bizarre interstellar visitor back to the most fundamental ingredient for life as we know it. With the evidence of a layered structure, a carbon dioxide-rich exterior, and a water ice interior, a leading theory began to take shape. This theory didn't involve aliens, but something just as fascinating: the brutal environment of interstellar space. The idea is that 3E Atlas started its life as a fairly normal, water-rich comet in its own star system. At some point, a gravitational disturbance, perhaps from a large planet or a passing star, flung it out of its home system and sent it on a lonely journey through the galaxy. This is where its transformation began. For millions, perhaps even billions of years, 3 Atlas drifted through the vast, empty void between the stars. During this time, it was constantly bombarded by high-energy cosmic rays. These are super-fast particles, mostly protons and atomic nuclei, that zip through the galaxy. This relentless radiation bath would have had a profound effect on the comet's surface. It would have broken down the water ice molecules in the top few meters, allowing the lighter hydrogen atoms to escape into space and leaving behind a concentrated crust rich in oxygen and carbon, which readily formed carbon dioxide and other carbon compounds. This process, known as interstellar processing, would have created the exact layered structure scientists observed. It formed a dark, tough, carbon and carbon dioxide-rich crust over the pristine, water ice core. This crust would also explain the 2 symmetrical jets. It's possible that 2 ancient impact events from long ago in its home system created weak points or fractures in the surface. These fractures became the path of least resistance. When the sun's heat finally penetrated the insulating crust, the pressurized water vapor from below would have erupted violently through these 2 specific points, like geysers through cracks in the ground. This theory elegantly explains all of 3 Atlas's weird features without resorting to extraordinary claims. The flattened coma, the symmetrical jets, the high carbon dioxide content, and the hidden water all fit into a coherent narrative of a normal comet that was fundamentally altered by a long and arduous journey through interstellar space. It suggests that many interstellar objects might have similar cosmic crusts, making them look and behave very differently from the comets born and raised in our own solar system. 3I Atlas wasn't weird because it was alien, it was weird because it was a survivor. Whenever an object from the stars visits, one question inevitably pops into our collective consciousness. Could it be them? Could it be aliens? The strange symmetrical jets of 3 Atlas looked so unnatural, so seemingly engineered, that speculation about it being an alien probe or vessel ran rampant online and in the media. Some suggested the jets were propulsion systems. The CIA's unusual silence and refusal to comment on routine astronomical observations only fanned these flames of speculation, creating a small media frenzy and leading to countless conspiracy theories about a government cover-up. It was a classic case of an information vacuum being filled with the most exciting possibilities. In response to both scientific curiosity and public interest, the SETI Institute and other organizations like the Green Bank Observatory turned their powerful radio telescopes towards 3 Atlas. Their mission was simple: listen. They scanned a wide range of radio frequencies, searching for any non-natural signals, any repeating patterns, or any kind of technological ping that would indicate the object was something more than a rock. They were listening for the hum of machinery, the chatter of communication, or the beep of a navigation beacon. It was a long shot, but one that had to be taken. After weeks of careful listening and data analysis, the verdict came in. The silence from 3 Atlas was deafening. The SETI teams found nothing: no artificial signals, no alien broadcasts, no evidence of technology whatsoever. The object was radio quiet across all monitored frequencies. While this doesn't definitively prove it isn't an alien artifact, it could be a dead probe, for instance, it strongly supports the theory that it's a natural object, albeit a very strange one. The lack of a signal was, in itself, a significant finding, helping to ground the conversation back in observable science. The story of 3 Atlas is a perfect preview of the future of astronomy. As new, more powerful telescopes like the Vera C. Rubin Observatory come online, we will be able to survey the sky with unprecedented speed and sensitivity. We won't just be finding one interstellar object every few years, we might find dozens. Each new visitor will be a unique messenger from another star system, carrying new clues about how planets form and the diversity of objects in our galaxy. And each time, we will look, we will analyze, and we will listen, continuing our cosmic search for answers and, just maybe, for a sign that we are not alone.